Hello team. In this video, we're going to talk about the MapReduce paradigm, what interface MapReduce provides us to build parallel applications. So let's consider the case that we want to count words in a book. So there's an input text, and what we want in the end is a table showing for each word in the text how many times that word appeared. So because we want to do data parallelism, the first step that we need is to split the input text. And there are many ways of doing this. One example would be to split the text into each chapter, and then we send each chapter to a different compute node. In the case of MapReduce, these compute nodes will be running map instances, and the map instance will receive text from a chapter and will compute the number of times that each word appeared in that chapter. And this is what the partial result would look like. So on the first map instance, we would have the counts for the words that appear in chapter 1, and then on the second map instance, we would have the counts for the words that appear in chapter 2, and so on. Now, as you can see, no map instance has complete information about the total number of times that a word appeared. For example, the word appeared 288 times in chapter 1, but the total number of times that it appeared in the whole text was above 10,000. So we need to join the partial results from each map instance. And what we talked about before in data parallelism is that we would have a combined step that would merge all of these results. So in MapReduce, we also have the combined step, but it's more advanced. First, there's more than one process to combine the results. So here we see multiple reduce instances. And second, there's this shuffle step in between. So the shuffle will distribute partial results computed by map instances to all of the reduce instances. So the load is distributed across these reduce instances. So here's an example shuffle. One way in which we can distribute the partial results from map instances across reduce instances is, for example, by the first letter of each word. We can send all words that start with A through E to one instance, and then words that start with F through J to a second instance, and so on. Now, one important thing here is that partial results for a given word need to be processed by the same reduce instance. So let's say that this reduced instance will receive all partial results for the word dog. So there are going to be some occurrences of dog in chapter 1, some occurrences of dog in chapter 2, and some occurrences of dog in the last chapter. And this reduced instance needs to receive all of these partial information so that it can compute the total number of times that dog appeared in the whole book, which is what we will have in the final result. And then finally, after the reduced instances have computed the number of times that each word has appeared, we just merge everything in a result file. And this merge operation is relatively straightforward. For example, the reduced instances can output the words in lexicographical order, and then we can also know which reduced instances get the first letters in the alphabet, and then the second reduced instance, and then the third reduced instance, and then it's easy to print, for example, if you want to do that, the words in lexicographical order like in a dictionary, so they would appear sorted. And we can give many examples of applications that fit the MapReduce paradigm. So let's say that we want to index animals in images. So we have a database of images, and we want to know for each animal which pictures that animal appears in. So in our result, we want to know for each animal, like cat, which pictures have cats. For dog, which pictures have dogs, and so on. So we can split the data set in different sets of images, and then split 1 might have this image, and then split 2 might have this image, and they might have other images as well, each split. And then the split will be sent to the map instances, and then the map instances will identify, they will run some animal detection code that's probably expensive to identify the animals that appear in each picture. So this picture has a turtle and a cat, so we're going to have on the first map instance a result saying that cat appears in picture 1.jpg, and then turtle also appears in picture 1.jpg, and then the second map instance will receive image 2.jpg, and then it will identify that it has a cat and it has a dog, and it will generate these partial results. And then we're going to send the partial results to reduce instances, and we'll need to have consistent shuffling again. So all partial results for cats need to be sent to the same reduced instance so that this reduced instance can build the list of images that have cats in them. And then finally, we're going to merge the result. So we can provide a mathematical formulation for how MapReduce operates. So the split step maps each data item D, for example, a chapter or a set of images, to a map instance MY. So there's this mapping of data item to map instance. The map instances will transform the data that they receive into a list, and each item in this list is a key value pair. Then the shuffle step will take the items generated by the map instances and map them to a reduce instance. So for each value generated by a map instance, the key will determine which reduce instance will handle that key. So the key has a value attached to it, and the reduce instance will need to process this value to compute the aggregate result, but the reduce instance that is in charge of this value is determined by the key. So in our examples, the keys that we had in the map outputs in the partial results were the words in the book example and the animals in the picture example. And then the values outputted by the map instances were the count of occurrences of each word in the chapter and the picture name where the animal appeared in the picture example. So coming back here, the key that the map instance generates is the animal name, like cat, and the value is the name of the figure where that animal appeared. And for each data item, for example, for this picture here, the map instance can generate 2 items in the list. It's okay. So there's one item with the key cat and value pic1.jpg, and there's another item, with the animal turtle and the value pic1.jpg as well. And then all items that have cat as a key will be sent to the same reduce instance. So the shuffle stage will send all values associated with a key j to a given reduce instance. But before doing this, the shuffle stage merges all the outputs from the map instances for a given key, and then it sorts values for that key and then sends these values to the reduce instance as an iterator. So this is why when we're writing MapReduce code, the reducer gets a key and then an iterator, which is a list of all of the values that the maps produced for that key. And here is a summary of the key value pairs that get transferred from one stage to another in the MapReduce pipeline. So we have the book word count example and the animal identification example, and we transfer data from split into the map instances, and then the map instance produces a result that's taken by the shuffle, and then the shuffle will merge and join and then send data to the reduce instances. So in the book word count example, what we get from split into the map instance is an offset into the text file and the line of text that was just read. Then the map will count the number of times that each word appeared in a line. So it will generate multiple outputs, one output for each word, and then each word will have a count telling how many times that word appeared in that line. And then the shuffle will take this output from all maps and then join them. So it will send to the reduce instance a key, which is the word, and then the list of all counts of how many times that word appeared in all lines in the book. In the animal identification case, we get from disk and send into the map instance a byte offset and then the contents of the figure that we read. And then the map instance will identify animals in that figure. And if there is at least one animal, it will generate a key value pair where the key is the animal that was identified and the value is the name of the file. And then the shuffle will take all of these animal file tuples that were generated by the map instances and join them. And then the shuffle will send to the reduced instance a key, which is the animal, and then the list of all files where that animal appeared.